Hello, class, and welcome to our last lesson of the module. The 3.2D lesson is on parallel and perpendicular lines. I know we've heard of the term parallel before, and now we're going to kind of familiarize ourselves with the word perpendicular in terms of slope. Okay, so let's start with an example where we draw a rectangle. We know that by definition, a rectangle is a quadrilateral that has four right angles, right? Later on, we're going to learn more about the characteristics of different types of quadrilaterals. But right now, just remember that a rectangle, by definition, has four right angles. Yeah, write that down. Four right angles. Okay, so let's go ahead and draw this rectangle. Apparently it has these vertices, okay? So let's graph carefully. A -5, 2, B 1, 5, C 3, 1, and D -3, -2. -3, -2. Is something off right now? I'm a little confused. -3, -2. That doesn't make a right angle. Just want to double check, make sure this is right. I mean, 3, 1, 1, 5, -5. Why did I write this as -5, 2? It's supposed to be -5, 2 right there. So I immediately apologize, class. I messed up on the very first question. And the very first point, it should have been A right there, B right here, C right here, and then D right there. So of course, I felt that something was wrong, and that's because I literally graphed wrong. Okay, so make sure that you do -5 and then 2. Okay, so our task is to decide if this quadrilateral that we just graphed is indeed a rectangle. Now, they did say it's a rectangle, so now let's find the slope of each side of the rectangle. So let's go ahead and write the slope of AB is, let's write the slope of maybe BC. Let's write the slope of AD. And let's also write the slope of DC. Right? Hopefully we'll see a relationship between the four. Okay, so the slope of AB is going to be a rise of 1, 2, 3, and then a run of 1, 2, 3, 4, 5, 6. Rise of 3, run of 6. Really, that's also known as a rise of 1 and a run of 2. AB is 3 over 6, which is 1 over 2. Now, AD is a negative slope, and it's 1, 2, 3, 4. 4 down and 2 to the right, which gives us -4 over 2, which is basically -2. And we know that BC, it kind of looks like AD and BC are parallel. And when I say kind of, I mean exactly. We know that AD and BC have the same slope, and it's clear and obvious because I calculated the rise over the run again, right? And we also know that DC looks like it has the same slope as AB. We can confirm 1, 2, 3, rise of 3, and then a run of 6. Okay, so we know it's 3 over 6, which is 1/2. Now, we said by definition that a rectangle has four right angles, right? And because they told us that this was a rectangle, I'm going to go ahead and draw these four right angles again. And what can you conclude about the slope between parallel lines and maybe perpendicular lines, right? Is there something you can see about the relationship of these ratios, right? So the first thing I notice is parallel lines have the same slope. Right? And this is seen in the parallel lines of AB and DC. But is there a relationship between the perpendicular lines, right? So class, let's do a recap. Perpendicular lines are two lines that intersect and create a 90-degree angle. Okay, these lines right here show a perpendicular relationship. Perpendicular lines, obviously one slope has to be positive and one slope has to be negative. The only time that that's not the case is when you have a vertical line and a horizontal line, right? That's the only time where it's not following this rule of one being positive and one being negative. But pretty much all the other lines other than vertical and horizontal will have one going positive in the positive direction and one going in the negative direction. Okay. Not only that, you can see that there's a relationship between these two slopes, right? And there's a word for that. So the word is reciprocal, right? So we could say, please write this down, perpendicular lines have opposite, meaning one's positive and one's negative, and reciprocal slopes. Okay, this is very, very important, and this is the theme of today's lesson. We know that parallel lines have the same slope, but now we have confirmed using our graph that perpendicular lines have opposite reciprocal slopes, right? Example being, if one slope m is going to be 1/2, the perpendicular slope to that would have to be -2/1. And that was the example shown in this rectangle. Okay, so you can already tell we are at the last lesson of the module. We've worked hard the entire time on calculating slope, and now we're going to add one last layer to your calculation. We're going to be given a variety of different looks, them being in standard form, maybe this is standard form, some other form that we're not exactly familiar with, but we know we can simplify to. And we're going to be asked a certain amount of questions on what's the current slope, what's the perpendicular slope, and what's the parallel slope. So you have to be very, very comfortable, class, taking something in standard form and isolating y to solve for it in slope-intercept form. Okay, so very first step, number 2, we already know that 4x plus 12y equals 24 is in standard form. So what I'm going to do first is try my best to isolate y. Right? So if I isolate y, I subtract 4x from both sides, and I get 12y is equal to -4x plus 24. I then am going to divide both sides by 12, and I end up getting, I'll write it on the bottom, y is equal to, now -4 divided by 12 is actually -1/3 x, right? 4 divided by 12 is 1/3. 24 divided by 12 is +2. Okay, so make sure that you are comfortable converting from standard form and isolating y. We now know that the current slope is -1/3, right? So if the current slope is -1/3, a parallel slope to that would also be, right? Let me write this in another color. Let me write this in sky blue. The current slope is -1/3. A parallel slope would be -1/3. And then the perpendicular slope would be +3/1, which is just 3. Okay, it's an opposite reciprocal. Okay, let's talk about these two scenarios, number 3 and number 5. So y equals 4. We know an isolated y is a horizontal line. We know that the current slope is 0, doesn't have a slope. Parallel slope would be 0. And then a perpendicular slope would look like a vertical line, right? A vertical line does not have a slope. It's undefined. Please remember, class, that 0 slopes are not the same as undefined slopes, right? So if you know the answer for number 3, number 5 should come pretty easily. If you have an isolated x equation, you know you have a vertical line on your hands, and we know that the slope is undefined. We know that the parallel slope is also undefined, and then we know that the perpendicular slope is 0. Okay. Okay. So I really like something like number 6. We really have to get used to, circling the equation of the line that is perpendicular to this current, kind of jumbled, mixed up equation. Now, the one thing I will say about this is not in any form. It's really all over the place. And for you to figure out which line is perpendicular, you might want to, I wonder what's the easiest route, right? Could I convert all of these to slope-intercept and then compare slopes? Yeah, I could do that, right? But maybe you want to kind of see the relationships between the coefficients, right? So let me go ahead and just first fix this equation. I'm going to multiply this equation by 2, just so I can get rid of the fraction. And I end up getting y minus 2 is equal, plus 2x is equal to 2y. Okay, so that looks a little bit messed up, but I'll say that one more time. I get y minus 2 plus 2x is equal to 2y. Okay, so then I'm going to subtract y from both sides, and I end up getting y is equal to, the isolated y on the right side, is equal to 2x minus 2. So essentially, class, we know that this current slope is 2. Now, we do not want the slope of these equations to be 2 as well, because that would mean that they're parallel. We don't want that. We actually want these slopes to be opposite reciprocals of 2. So we're actually looking for a 1/2, and not only a 1/2, we're looking for a negative 1/2 slope. So using your judgment, go ahead and think which one of these has a negative 1/2 slope. Well, very quickly, I know when I look at these, I can just kind of push the y's to the other side, and I can already tell that the slopes are going to be 2, or maybe negative 2, but we know definitely not, the slope will not be 1/2. So I can already eliminate A and C. So now the question is, which letter, B or D, has a slope of negative 1/2? I'm going to go ahead and try B. If I subtract x from both sides, I get 2y is equal to negative x. And then if I divide by 2, there it is. I can see that B has negative 1/2 x. I know I wrote it next to D, but B is the one that has the perpendicular slope that I'm looking for, right? With experience, when you do problems like this more often, I say this all the time, but obviously you'll have more familiarity of comparing slopes. So it's really just a trial and error kind of thing, but go ahead and, yeah, put some thought into that and think why B was the right choice. Okay, so number 7 through 9, it says, without graphing, determine whether the lines through the pairs of points are parallel, perpendicular, or neither. right? It obviously can be neither, as long as the slopes are, not opposite reciprocals or not the same. Okay, so this is a very good exercise to calculate slope. Let's just do one. I'll just try number 8. Let's do the first one, 7 minus 4. And maybe it's good to color code. I have a lot of different colored pens and markers next to me. So maybe the first one I'll do in black and the second one I'll do in red. So the first slope is, I'll call it M1, is going to be 7 minus 4 divided by 3 minus negative 3. Okay? And 7 minus 4 is 3. 3 minus negative 3 is 6. It's a plus, right? And then this is 1/2. And now I'm going to do the second pair of points in red. And let's do 6 minus 2, right? y2 minus y1. Negative 2 minus 4. This ends up being 4 over negative 6. And this is negative 2/3. So, well, these are not reciprocals of one another. They're definitely not the same value. Number 8 is going to be a neither. Okay. Okay. So maybe you should go ahead and try number 7 and number 9. And at this point, I think I'm going to take a break. Let's come back to part 2 and see which part of the lesson that we want to complete as a class. But go ahead and try 7 and 9.